So welcome to the TestWizardry class today. We're going to cover object-oriented programming and get started with writing our game. I know the last few days we've gone through a lot of Java basics, which may be review for some of you, or it may be new stuff. So I'd like to know, give me feedback if it's going a little too fast or too slow. I feel like it's taking longer, but that we're not covering as much information as we could. So today we're going to step right into the code, and I will discuss object-oriented concepts while we start writing a command line version of this game, or the simplest first steps of it. So what I'm going to do is I'm going to just go ahead and close this project and start creating a new one. So I'm going to create a new Java project, and I'm going to call it TestWizardry. And again, everything else should be able to be default. So I'm just going to click finish here. And now I have my TestWizardry project. I don't need to create that module info. Let's go ahead and I'll just delete this out of the way. All right, so I have this empty project, and first thing I want to do is I want to create our main class. So right here in our default package, I'm going to create a package. I'm going to call it TestWizardry console. And by console, I mean it's going to run from the command line. We'll create a web interface later once we've defined our basic UI, or our basic functionality, not the UI. So what do we need? We need a main class, or a main method. So let's actually delete this. And I want to show you one more thing. Rather than deleting, I was going to show you how you could add the public static void main, but I'll just type it. Public static void main string array args. And the first thing I'm going to show you is going to be a little bit of magic, I guess, in that I'm not going to explain what it's doing or how it does it. But, well, not the very first thing. Let's start off with something simpler. I'm going to show you how you can read from the console next. But first, let's print to the console. So first thing, let's start. We'll just put our title, TestWizardry. Maybe we'll call it Welcome to TestWizardry. And run our program. Click the little green triangle here up at the top, and it says Welcome to TestWizardry. Going to the console, we can see I can go here and I just need to juggle. It has the zoom stuff imprinted over my screen, so I can't see that. So what I want to do is I want to go to this directory, this TestWizardry workspace, the TestWizardry project, and show you how it looks from the command line as well. So I'm in this directory, and you can see I have my bin and source, so I can Java bin TestWizardry console. Could not find her logo. Oh, because it is in the, all right, Java TestWizardry console. That's better. Welcome to TestWizardry, just so I can do it from both sides. All right, so welcome to TestWizardry. Did I see someone else needed invited in? No, I guess everyone's in for right now. All right, so now there is a class called Scanner. And what it does is it scans standard input for any message. So any sentence or anything you're going to type, any line of input you're going to type. So scanner input, or you can call it scanner, or you can call it, John if you want, but I'm going to call it input equals new scanner. And this is the bit of magic, system.in. That's the standard input interface. And you can see scanner still underlined, and I've got this X, shows me an error. It says import scanner from, we want Java util scanner. There's different versions of scanner, which I might as well start by showing you. It's java.util.scanner. This is one area of information hiding in Java that it has a package. And as a matter of fact, let's put this in a package. We'll call it TestWizardry. Now, packages are optional, but it provides a way to group things separately. So let me show you, there's an error here. So it says move it to the package TestWizardry. Eclipse will create this package. And now you can see under source, we have this other thing, this little plus in a square. That's a package TestWizardry. So scanner is in Java util scanner. My TestWizardry console is in TestWizardry package. So that's one way that you can group things. I can make another package, new package, and I can call it something else, whatever. And I have now this other package, and I can create a new class, and I can call it TestWizardry console. And that works. Now, if I tried to move it here, it won't work because I can't have two classes in the same package with the same name. But if they're in different packages, they can have the same name, which is why you saw there were so many different options for scanner. The scanner we want is Java util scanner. That brings us to one of the principles of object-oriented programming, but we'll talk about those in a couple minutes after I go through the next step. What we want to do is we want to ask system out print line, what is your name? And this is much like the hello world, but this is how we're going to start the game. We want your name. We want to know your age and your gender, so we can refer to you as a witch or a wizard. And then we'll use these items to create an algorithm to sort people using the sorting hat into different houses, Gryffindor, Slytherin, etc. So what is your name? Now, what we can do is we can do input dot get or not get next line. So you can see there's all these different methods that Eclipse is very handily just hinting at. We just want to get the next line because it's going to tell us the name. Now, what does this return? Eclipse will show me. It returns a string, or the line that was scanned. So we want to do this. Name equals input next line, and then we can do system out print line hello name. And we see we take this string literal hello and we combine it with name to concatenate them together. And let's just go ahead and run our program. This is not surprising. This is everything you've done before, except when it says, what is your name? The program is still running. You can see this little red dot here, or this little red square. Now I killed the program and it goes away. I'll start over by running it again. What is your name? Well, I'm going to type my name, Aaron, and it says, hello, Aaron. So this gives us a way to work interactively. And then we can ask, what is your gender? And again, we can get the next line. Now you can see there's a lot of repetition in what we're doing here, and we're gonna just bear with this, right? Bear with me right now for this. We can group these into smaller segments, kind of grouping our class or our functions. You know, we've got a section on name, we've got a section on gender, and we'll have a section on age. What is your gender? And now we're going to say you're a wizard, but we need it to say based on your gender, whether you're a witch or a wizard. So what is your name? Aaron. Hello, Aaron. What is your gender? Male. It just says you're a wizard. So what we want to do next is we want to say you're a wizard if male and you're a witch if female. So if, that's the key word we use, if gender. Now with numbers we can do if 1 or if 11 equals 10 plus 1. And notice the 2 equal signs. If you use 1 equal sign, it assigns it, and that won't work. You can't assign a number to a number. You can only assign a number to a variable. Well, let me do this a better way. So if age equal to 11, and we'll jump ahead to that in a minute. We'll do something. But what we want to do, the same thing with gender. If gender, we don't use equal sign, we don't use dot equals, because classes don't use operators, with the one exception of you can plus strings. Hello plus name equals hello Aaron, or whatever the name variable happens to be, or whatever other string. But equals doesn't work the same. You can't use equals equals for a string. And so what you do is you call this method equals. Equals is a function which takes an object, in this case another string, equals male, then say you're a wizard. Else, meaning if it's not male, what we want to do is if gender equals female, then we print you're a witch. Build a bridge out of her. Oops, got a typo there. Got another typo here I'm not seeing. Oh, else if. We could assume that if you enter male, you're a wizard, and if you don't, you're a female and you're a witch. But what if they type something wrong? Or there's multiple genders. System out, print line. For the case of simplicity, we'll do that. So what it's going to do is it says please select male or female. Now we don't really have a way to do this. We could go to gender, and in Java you don't normally use goto, but in order to do, you need to put a label. And I just want to bring up an example because I haven't used it in a million years. Yeah, so you just put a label with a colon and goto. Now, as anyone might know, if they've read goto considered harmful. duplicate, go to all right. We're not going to worry about that right now. We'll bypass the question for now. So let's go ahead and run our program again. What is your name? Oops, I've got to click down here below. Aaron, what is your gender? Male, you're a wizard. And that's all it does for now. Now, the next thing we're going to do is age. Now, as everyone knows, who's a big Harry Potter fan, when you're admitted to Hogwarts is when you turn 11 years old. So if age is 11, then say, happy birthday. You've just been accepted to Hogwarts. And rather than signing it right there, we would use a input next. Now we want to get next int, not next line, because then what it'll do is it will cast it to an integer. If we get next line, well, next line returns a string. See, so it wants to change type of age to string. So this is one example of what we call polymorphism. And we'll get to that as well, that it behaves differently based on your inputs or outputs. But let's go ahead and run this. And then else, we want to, there we go. I think it's quicker for me to type it out than to remember the hotkey. All right, then print, well, we want to go if age is greater than 11, we want to say, you are too old. To attend Hogwarts. Maybe we should say too old to start at Hogwarts. And then else if age is less than 11, system out, print line, and I'm going to post all this. You are too young for Hogwarts. All right, so you see what we've got going on here. We're not doing anything object-oriented yet. We're just kind of building up our game, but we've got all this stuff that gets kind of complicated, right? We're writing a lot of sequential code. Input is never closed. Okay, so we want to also do that at our end here. Input.close. So we'll run through this. What is your name? Again, Aaron. What is your gender? I could say female, and it says you're a witch. Oh, I didn't. Now it'll accept an input. That's obviously too old to start at Hogwarts, but I didn't say how old are you? So let me go through this one more time. Maybe I'm Hermione. I'll mistype. I don't know that answer. How old are you? 11. Happy birthday. You've just been accepted to Hogwarts. So this is the basics of our getting going. And what I want to do now is talk a little bit about object-oriented programming, and I'm also going to switch over to another version of this same example. And this code looks very similar, but it's a little bit cleaner. We still got the same scanner, right? We say, welcome to TestWizardry. What is your name? This all looks very familiar. Input next line is first name, last name. Hello, tell me a bit about yourself. Are you male or female? First thing you might notice is rather than system out print line, I'm using print because it gets hard to type out over and over again. So what is print? Well, print is another function. In this case, it's not doing much. It takes a string, that's the message that you want to print, and it just writes system out print line. It does make it, however, a little bit cleaner. It saves me on typing at least, and it makes it a little easier to understand. So this is kind of the first thing, that you can create functions and reuse those functions. In this case, it's a method. Another thing is, we're going to be developing a web version of this game as opposed to a console version. And so it might print this on the web page instead of on the console. No, I don't want to do that. So that's the first thing, is we can create a function that would group things separately. Now, the next thing we see is, well, we have this issue with gender. That is that someone could mistype their gender or choose a gender that's not recognized by the game, right? It says, I don't know that answer in this case because I misspelled female quite horribly. So what do? We create something, we create an object called a gender. Now, in this particular instance, I'm creating something called an enum. An enum is something that enumerates, so it gives specific values, male and female only. So let's hop on over here, and what I want to do is, the first thing I want to do, let's not worry about the gender. First thing I want to do is I want to create a class, and the class I want to create is called a wizard. Now, I did some research, and in the Harry Potter universe, there are wizards and muggles, right? So a wizard is a person who uses magic. A muggle is a person who can't use magic in the simplest forms. So, but they're both people. So what we want to do is we want to create a class called wizard. Now, a wizard has a name. It's a string. Your name is a string. As a matter of fact, let's go ahead and copy that other example. It has a first name and a last name.
But is that a real meeting or not?
Yeah. A wizard also has an age. That's an integer or a number. And a wizard also has a gender. And so we'll start off with string gender. And now, the next thing I want to talk about is, what is a class? A class, and let me hop on over to PowerPoint for just a second. Oops, that's the wrong side. I wanted a class. There's two concepts here, a class and an object. Essentially, a class is a template or a definition of an object, right? So we're looking here at our wizard. We're saying a wizard has a first name, a wizard has a last name, a wizard has an age and a gender. These are all properties of a wizard, right? And there's two different things you associate. There are things with an object or a class. There are things a wizard is, or let me back it up. Let me just read through this bit here. So a class is a template or definition of an object, right? So here we're defining what this template is. Now an object is an instance of a class. So let's go ahead and create an instance of our wizard in our console game here, right? So we want to create a wizard. and we'll just call it wizard. And you'll see this in Java a lot. This is one of the things that makes it very worse. We create a wizard, we call it wizard. Maybe we'll call it me to just make it easier to see. So I'm a wizard, me. And now I'm going to go ahead and assign my name. Let's not worry about last name for now. Well, we can keep that and not worry about it. But so what is your name? Now, string name equals input.next line. What we want to do is we want to do me. Well, let's change this to, yeah, let's just keep it at wizard. So wizard dot first name equals, we're going to read the name, and then we want to do wizard dot or period first name. Now you can see this is underlined. What we've done is we've declared a variable, right? And if you remember, when we declare an integer, we say int age or string name. That we're declaring it. Now, there's two parts of the declaration. There's the type. In this case, the type is wizard instead of integer or instead of string. The name, we're declaring a type and we're giving a variable a name, right? Let's actually just, let's do this easy. Well, this is kind of ridiculous. So we've got a wizard named Harry. And Harry, well, his first name is Harry, or whatever it's going to be. And I don't like this example either. We'll go back to wizard. We've got a wizard. I just wanted to point out that the name of this variable wizard is called wizard. Now, the next problem we have is that it hasn't been initialized. So we declare it with a type and a name, and then we assign it a value. In this case, what we want to do is we want to create a new wizard. If I can type. All right. So new is a keyword. It means create an object of this type or of this class. So create me a wizard of type wizard, which seems redundant, right? We've got wizard 3 times here. But excuse me, but that's a little bit redundant in Java 14 and 15. So in the last year, Java has made it so that you can type var. Now this won't work on Java 8 or 9 or older versions of Java, but we can say var, which is short for variable wizard equals new wizard. And what it will do is it will infer at compile time that it's type wizard. Now, this will only work when it can infer, but we're going to leave that out for now. I just wanted to point that out for the sake of clarity for the future, because I don't want to just teach you old code. I want you to also understand what's new and upcoming. Most code you see will still not use var. All right, so we've got a wizard named wizard of type wizard. And he has these attributes, right? He has a first name, a last name, an age, and a gender. So we can go through and we can get the first name, get the last name. And you know what? Let's keep this as name just for brevity, because I want to show you something else. Now let's go ahead and create a function, right? Let's do, let's call it ask name. And so what we would do is we would create another function. And this is going to turn a string ask name. Now, what I'm saying here is that this is a public function. It's also going to be static for now because we're referencing it statically from our main. I'll explain the difference to that later. And we want to ask a name. And then we create a block with these brackets, these curly braces. And why is it complaining? It says we need a return statement. It's returning a string, right? We could return Harry. But what we actually want to do is we want to take all this stuff about asking a name and move it down to this function. And then what we want to do is we want to return name. Now, input, it says cannot be resolved. Why is that? Well, input is this scanner that is created in the main class. It only exists in main. So what we want to do is we want to make it accessible to the other methods. Now, there's a lot of stuff going on here that we're going to brush over. So outside of the class, we're creating this scanner. Now, it's still not accessible. Why? Because it's not static. So we can create a static scanner. And then what I'm going to point out is that we want to assign it in the main class. So I missed my semicolon. What we're doing is we're creating a static scanner called input. So scanner is the type, input is the name of it, static is a qualifier, which says there's only one instance of this scanner for the entire class. Because we're not instantiating this class, we're using it with a main. This is the entry point to our program. If you don't understand that, don't worry. Just consider it boilerplate code that you have to type for now. All right, so we have a new scanner called input. And now, because it's outside of any single method or function, it can be accessed anywhere within the class. So within our main method, we can access our input scanner. And in our ask name, we can now access our input scanner. So you see that? And then we've got all of this code that we'll group together. What it does is it says, what is your name? It reads the next line. It says hello, and then it returns the name. Why do we want it to return the name? Well, because we want it to assign it to the wizard. First name equals ask name. Let's go ahead and move this up here at the start of our program. Okay. So we've got our setup code, right? We're creating a new scanner that can be accessed. We're creating a wizard here, and we're getting their first name. Let's do the same thing. Wizard dot age equals ask age. Now we're going to take, I guess we've got gender first. We'll do age next. We'll take this out and we'll move all of this down into its own function. Public static int for integer, ask age, create a block with our curly braces, and paste the code in here. So it asks how old are you? It gets the input age and assigns it to a variable called age. See, it needs a return type, so let's add a return type. It can actually get by without me typing. So it returns the age. Now what I want to do is I want to make sure that if someone doesn't enter the right age, they have another chance. But I'm not going to worry about that right now. I'm just going to format this a little bit. So we've got this test of age, and we return the age. Wizard age equals asked age. Let's do the same thing with gender, and then I want to show you what we can do for that. So we'll create another method. We'll call it public string ask gender. And you see this wants to return a string, so we'll add a return statement. I'll do that manually this time. I'll just type return string. And what I should do is I should make this bigger so we can see it. So we've got a lot of code written here. We don't want to return string, we want to return gender. And we've written these three functions, which are methods. And we've simplified our code a whole lot. Now, doesn't that look a whole lot more readable? Oh, yep, we need to change ask gender, public static string ask gender. So our main function is now very readable, right? By creating these methods and by creating this wizard object, we have, we create our scanner, and this is kind of just a setup, and we close our scanner at the end. But then we create a new wizard. We ask the wizard his name and assign that to first name. Same thing, we ask them their age and assign it to their age, and we ask their gender and assign it to their gender. Now, we've put a lot of things in here that might not make sense to be in these functions. For instance, asking the age doesn't necessarily have to coincide with deciding whether or not they can go to Hogwarts. Same thing, telling them whether they're a witch or a wizard might not necessarily be involved with asking their gender. But that's the first step in our abstraction. Let me take a minute here to talk about this in a little more detail. So every function or method, the terms are interchangeable, has a name. That's kind of obvious. You can see there's a convention I'm following, and this isn't a rule. This is just a common practice. You can see a class name starts with a capital letter, and each word in there is capitalized. I could use underscores or numbers, and that's about it. In these, either a class name, a function name, or a variable name. But the standard convention within Java programming is classes start with a capital letter, and each word is put together with no spaces, because multiple spaces equals multiple words or multiple expressions. So this is the convention in Java, that a class starts like this, and a method or a function starts with a lowercase, but each additional word is uppercase. You can also often see, sometimes you might have ask underscore name, and some other programming languages follow that convention. It's perfectly legitimate, but it's not enforced either way. But by convention in Java, we do it this way. All right. Now, working back from the end, we have the name, and then we have the return type. And you can see string is return type. It returns name, and name is a string. Now, public and static, these are just accessor variables. Public meaning it's available to the public, and static meaning that it's only one instance per class. Don't worry about that now. And then the last thing is the parentheses on the end, jumping forward. These are the parameters. There are no parameters in any of these functions. They're just simply sending no information and getting some information back. Now that we've refactored our code and made it more readable, we can run it again. and we can see what is your name. We'll say Harry. How old are you? 11. Happy birthday. Oops. What is your gender? I don't know if I pressed a key or if I introduced a bug. Harry, how old are you? 11. Happy birthday. Yeah, it looks like I introduced a bug. So we'll go back in here and figure out what I did wrong. And then I guess also, because the age determines their admittance to Hogwarts, we want to actually ask that after gender. And just by moving this single line of code, we've now changed the order of execution of the statements. So it'll ask for their gender first. And you can see, even though the functions are in different order, it doesn't matter down here. What we want to say is, are you male or female? That will give a little bit of a hint on what to write. And it says you're a wizard or you're a witch. Now, oh yeah, I needed to figure out what's wrong with that. Oh, I think it's it has to do with the scanner. Now that I've done it in a different order, it should probably succeed. My name is Ron Weasley. Hello, are you male or female? Male. You're a wizard. How old are you? 11. Happy birthday. You've just been accepted to Hogwarts. Okay, so what's going on here is this next int doesn't read the whole line. And so when I read the integer and press the enter key or the return key, then it reads that return key as the next answer. So there's probably something we could do to make sure that will work better. But in this case, we don't need to worry about it. What I wanted to go do now is talk a little bit about object-oriented, right? We talked about classes and objects. So we've had a little bit of a sample. We have, number one, we have our main class, that TestWizardry console. But we also have our wizard class. Now, an object is an instance of a class. And here we have the class wizard, which is this template. And we're creating an instance of wizard, and we're getting all their values. Now, a class has properties. Those are the variables, right? The name, age, gender, and methods. Now, methods is functions, and our wizard doesn't have any functions. A class doesn't have to have functions, but it often does. The next thing is we want to talk about inheritance versus competition, or composition, excuse me. A wizard is a person, and a person has a name. All people have names. Not all people are wizards. So that's kind of a flaw, but all wizards have names. That's kind of a logical test right there, right? Are all wizards people? Yes. Are all people wizards? No. So what I want to do is talk about inheritance. A wizard is a person. So, and a wizard also has methods. What sort of things does a wizard do? Well, I thought to myself, a wizard does a few things. Probably cast a spell is the first thing a wizard does. So I'm going to create a function called cast spell. And I'm going to create this as an empty function. It doesn't have any definition. It doesn't do anything. Well, let's go ahead and add. We'll do Wingardium Leviosa. I think that's the first spell you learn when you're watching Harry Potter or reading, perhaps. Wingardium Leviosa. Let me know if there's another spell that you'd prefer. But anyway, so this is our first spell. It's not doing much. And the other thing I thought is, well, we can't leave Snape out. Muttering incantations or whatever Professor Snape says. He's a potions guy. And so we want to recognize that wizards can also brew potions, right? And you know, Harry Potter's great, but I'm gonna mess up my hair. Bubble toil and trouble. I'm trying to do my Shakespeare here, and now I'm messing it up. Shakespeare, witches, quote, bubble. All right. Double toil and trouble, fire burn and cauldron bubble. That's the full quote. Double bubble toil trouble bubble. All right. All right. I guess they're probably casting a spell while they're brewing that potion in that cauldron in Macbeth. But anyway, so now we can cast a spell and brew a potion. Any wizard can do that. And we'll talk a little bit about more how we're going to change that. But then we can go in here and we can we could say wizard cast spell. And now it's going to perform casting a spell. Let's do that at the beginning because actually let's I really want to introduce testing concepts to you now, but there's not enough time. So what I'm going to do is I'm just going to do cast spell before asking your name. And then you can see it. You wave your wand and say the magic words. There we go. Get a little bit of character. Say the magic words, Wingardium Leviosa. And we can actually even put that here as a, remember we can call a method, got an extra semicolon, we can call a method, and that is one type of expression. Now, oops, we can't quite do that because it says, what does it say that is? Does it say type null or type void? Yeah, so we can't add a void to a string. So if we returned that instead of printing it, so we won't do that right now in the interest of time. We can cast a spell and we can brew a potion. All right, you wave your wand and say the magic words Wingardium Leviosa, and then all right. Now we can see you wave your wand and say the magic words Wingardium Leviosa. You mix the ingredients and stir the pot. Double toil and trouble. Gotcha. All right. So we now have a wizard who can cast spells and brew potions in a manner of speaking. They also have these attributes. Now, the last thing I want to show you is inheritance. I talked really briefly about, let's see, I don't have something specific on inheritance in the slides. So we'll go back to the user interface. What I wanted to point out is that a wizard is a person. So class wizard extends person. And all of these attributes, first name, last name, age, and gender, are not attributes specific to wizards. They're attributes of people. So this can help us out, right? When we say person cannot be resolved, it says create a class person. Well, I will just create one over here. I'll go new class and call it person. And now a person has these attributes. And we could we could create a method called speak. It's not the same as casting spells, but it works. System out print line words. So now a person can speak and say the words, and a wizard is a type of person. So what we can do is we can say speak Wingardium Leviosa. Because a wizard extends a person, it inherits not only the properties, but the methods of person. And we can also speak with our potion. Although really, speaking isn't technically part of brewing a potion, I think. But anyway, this will do for now to show us what we've got. So we go back to our console, we cast a spell, we brew a potion, and it uses speak to do those things. And maybe when a person speaks, maybe it says something like, we'll put some space in and you say, like that. Now it's going to append or prepend you say before anything you say. Another thing it might do is it might, in a web interface, if this were a comic strip, put a bubble of text over a picture's head, or it could, use audio to interpret it. And now we can say, see, you wave your magic wand and say the magic words, you say Wingardium Leviosa. You mix the ingredients and stir the pot, you say double, double, toil and trouble. So inheritance, a person has these attributes or these properties and has this method, speak. A wizard inherits all of these things from person. Now, I was thinking about this and I thought, well, in Harry Potter, there are witches and wizards, and a witch is like a wizard, except it's a female. It's like saying mankind encompasses man or woman, and this is the research on the internet. Correct me if I'm wrong, but wizard kind encompasses wizards and witches. So the point I'm making here is that we might have another class called witch. And a witch also extends person. And so it inherits all of those attributes. And we could create a witch. Here we go in our console, right? So we could create a witch, call it witch, and create a new witch. And then we can set the witch's age and name. And the witch age is 11. And witch gender is female. Now, what I want to show is something of encapsulation, and this will be the last thing I do today, that we can say a witch, we know a witch is actually like a wizard, but they're a female. So a witch, what we want to do is we want to create a constructor for witch. So a constructor is a function or a method that's called, right? When I call new witch, it's calling the constructor. That's why you see the parentheses, because I have a constructor, and the way I create a constructor is I create a function, but it doesn't have any return type, and it has the same name as the class. So what I want to do is I want to say, when I create a witch, I want to say gender equals female, because it's implied in the name of witch. And so which, here we go. I guess I haven't gotten far enough. What I wanted to do was show that if I create a witch, it will say you're a witch. Whereas if I create someone who's not a witch, it won't know they're a witch. And I wanted to show public and private methods or properties. So maybe we'll pick this up tomorrow. But I want to show. Here's what I can do. Rather than typing, I will show. So I don't have witch here on this example. And I just switched to another version of Eclipse, the one running on my Windows VM. All right, so let's go ahead and stop there since our time is up. But we'll pick up tomorrow with, we're going to distinguish the gender of witches and wizards. All witches are wizards, but not all witches, or not all wizards are witches. And what we're going to do is we're going to talk about making these variables private and having them accessors so you can only control them in some way, so that you can't create a witch and by definition witch is a female, at least in the Harry Potter sense, and wizard is a male. So a wizard or a witch will have their gender set at the beginning, and that way you can say you're a wizard or you're a witch automatically. And we'll correct it so that it doesn't have any errors for typos. And that's what I showed with the enum. So we'll talk about public, private, protected, accessors. We'll talk about how you can handle polymorphism when you can't have multiple inheritance in Java, because Java does not have multiple inheritance. So you can't be both you can't extend person and extend magic user, because both a witch and a wizard are a magic user and a person, whereas a muggle is a person but not a magic user. We'll talk about using interfaces as well as classes for inheritance to achieve something similar to, but not quite, multiple inheritance. And we'll talk about abstract methods and abstract classes as well on tomorrow's lesson, and kind of refine this so that our code is actually even cleaner and more flexible, so it's not tied to this console version of just printing out the text. All right, well, thank you all for your time today, and we'll see you tomorrow.
Thank you.